Hello everyone, today I will discuss about this topic, discrete random variables. I'll take this file from Pepper Cambridge site so you can take a look at that website. So let's jump into the first question. I have a couple questions, I have 5 of them. Okay, first question. Hazim repeatedly throws 2 ordinary fair 6-sided dice at the same time. On each occasion, the score is the sum of the 2 numbers that she obtains. Find the probability that it takes exactly 5 throws of the 2 dice for Hazem to obtain a score of 8 or more. Okay, so that means for first throw, he not obtain a score of 8 or more. So we have 5 throws. Okay, this is the first throw, then the second throw, and so on. So the first 4 throw, he doesn't have a score 8 or more. Okay, and exactly on the 5th throw, he obtained a score 8 or more. So we calculate probability of getting 8 or more first. Yeah, getting 8 or more. How are we gonna find this? Of course, we can draw a table. We throw 2 fair 6-sided dice, so we have like this. Okay, we have we add the number. Yeah, so we have 2 3 4 5 6 7. Okay, so we count how many number in this table have 8 or more. So we have this. Yep, so we have 1 2 3 4 5 6 7 8 9 10 15. So we have 15 of them out of 36 possible outcome. That means probability of getting 7 or less. So we count all of this. That means this is 36 minus 15. We have 20 number out of 36. Okay, in the first 4 throw, the probability is 21 out of 36. That means each throw have probability 21 over 36, 21 over 36. Yes, like this. And for the 5th throw, he get 8 or more, so we have 15 out of 36. So the result is probability equals to 21 over 36. You raise with 4 and then multiply with 15 out of 36. If you calculate using your calculator, you have 1248832. This equals to 0.0482 up to 3 significant figures. Okay, this is still easy. Okay, for B, find the probability that it takes no more than 4 throws of the 2 dice for Hazim to obtain a score of 8 or more. So let's say X is a random variable that represent on which throw she get 8 or more. Okay, so we need to find she no more than 4 throws. Okay, so X, it can be 1 2 3 or 4. So we count probability of each of these X. So probability of X less than 4 equal to probability X equals 1 plus probability X equals 2 plus probability X equals 3 plus probability X equals 4. Probability x equals 1, that means she obtained a score on the first row and then she stops because he already have a score of 8. Yeah. So the probability itself is probability of getting 8 or more, 15 out of 36. And then probability x equals 2, that means we have 2 rows here, and the first one he get a 7 or less, and the second row she get 8 or more. So the probability equals to 21 out of 36 probability of getting 7 or less times 15 over 36, and probability x equals 3. On the first 2 row he got 7 or less, so probability is 21 out of 36 square times 15 over 36, and for the last one she get 8 or more on the fourth row, that means the first 3 she get less than 8. So 21 out of 36 cube times 15 over 36, and the result is 18335 over 20736, or this is equals to 0.884, 3 significant figures. Okay. Now for C, for 8 randomly chosen throws of the 2 dice, find the probability that Hazim obtains a score of 8 or more on fewer than 3 occasions. So this is the binomial distribution questions. So we have 8 experiment. Yeah. So we have 8 throws, and for those of 8 throws, we need to find probability Hazim obtain a score on fewer than 3 occasions. That means it can be a 0, it can be 2, it can be 1, or it can be 2. So let's say our x, our random variable, will represent the number of throws obtains a score 8 or more from 8 throws. Okay, so our objective is to find x fewer than 3, that means it can be 0, 1, 2. Why 0 is possible here? So if x equals 0, that means she never get 8 or more on those of 8 throws, and for 1, that means she exactly have 8 or more from those of 8 throws, and 2, she exactly have 2 8 or more. Yeah, so we calculate probability x equals to or less than or equals to 2. This one divided into 3 parts. Probability x equals 0, x equals 1, and x equals 2. So the answer is, remember the formula of binomial distribution. We have our x. So okay, I'll write first the distribution. X following binomial distribution with our n, which is how many experiments we have, which is 8, and probability of success. Okay, success in this questions means you got 8 or more. So probability of success equals to probability of getting 8 or more. Yeah. Okay, so the P equals to 15 over 36. And remember the formula, probability of x equals to n r. So x equals to r, let's say, n r p to the power of r, 1 minus p to the power of n minus r. Okay. Probability x equals 0, that means they always scoring 7 or less. That means this 1 minus q, 1 minus p, which is 21 out of 36, power of 8. Or if you follow this formula, you have like this 8c0, which is 1, it doesn't matter, 15 out of 36 power of 0, because they never got 8 or more. And then you multiply with 21 out of 36 power of 8. That means from those of 8 rows, she got 8, 7 or less. Okay, for probability x equals to 1, we have 8c1 times 15 out of 36 power of 1 times 21 out of 36 power of 7. Probability x equals to 8c2 times 15 over 36 square times 21 over 36 power of 6. Okay, so just calculate each of this. You get 0.282 to 3 significant figures. Right. Okay, this is the end of number 1. Let's see number 2. A red spinner has 4 sides labeled 1, 2, 3, 4. When the spinner is spun, the score is the number on the side on which it lands. The random variable x denotes this score. The probability distribution table for x is given below. Show that p equals to 0.12. Okay, this only one mark. This must be easy. Okay, so for this question, you need to remember the properties. Sum of probabilities equals to 1. Yeah? So we have 8 outcomes here, and the sum of this probability must be equals to 1. That means 0.28 plus p plus 2p plus 3p equals to 1. 0.28 plus 6p equals 1. 6p, I take 0.28 on the right side. 0.72, that means p 0.72 divided by 6, so we have p equals to 0.12, which was correct. Okay, for number B, okay, we have information here. A fair blue spinner and a fair green spinner each have 4 sides labeled 1, 2, 3, 4. All 3 spinners, red, blue, and green, are spun at the same time. Find the probability that the sum of the 3 scores is 4 or less. Okay, for these questions, the score is 4 or less. It means it can be, okay, because all of these spinner have outcome 1, 2, 3, 4. The minimum point of the sum of the string number it can be produced is 3. It can be 1, 1, 1. The maximum value is 12 if all of them score 4. Okay, that means this question we need to find just 3 or 4, because the objective is to score 4 or less. Okay, if the sum of score is 3, it only one probably only one possibilities here. Red score 1, blue score 1, and green score 1. And then we multiply the probability of each spinner. Remember, the blue and the green spinner is fair spinner. That means each of this number have probability 1/4, while the first spinner, the red spinner, have this following this table distribution. Okay, so 2, the probability of getting 2 on the red spinner equals to 0.12. This one is 0.24. This is 0.36. Okay, so this number have probability 0.28. Okay, multiply 0.28 times 1/4 times 1/4, and we have 0.0175. Okay, this is the only way produce 3. And the second case, if the number is 4, the sum of all numbers is 4, it can be 112, 112, or 121, or 211. Okay, so for the first case we have 0.28 still, and 1 is 1/4, 1/4. So we have same amount of number. I'm gonna write this red, blue, and green, yeah. Okay, and then 121 is also same number, and for the last one, 211, let's see the probability of getting 0.12. 0.12 times 1/4 times 1/4 is equals to 0.0075, and the probability itself, you add this together, so you must have 0.06. Okay, this is quite good number. Alright, for C, find the probability that the product of the three scores is 4 or less, given that X is odd. So remember, X is the number or the score from the red spinner. Yeah, this is the X. Okay, this is the conditional probability. So this is our first event. Let's say this is A and this is B. So the question is probability of A given B. Okay, probability of A intersect B divided by probability of B. Okay, so first we calculate probability A intersect B. That means product of the three scores is 4 or less. As remember, this is the product, not the sum, like the previous questions. Because all of this spinner have 1, 2, 3, 4 outcomes, the minimum product score that can be produced is 1, because it can be 1, 1, 1, and the multiplication of 1, 1 is just 1. 1, it can be happen, 2, it can be happen, 3, and 4. So we have 4 possibilities for A. It can be 1, 2, 3, and 4. And then if X is odd, that means we get X equals to 1 or 3. Okay, let's say I give you the table here. This red, blue, and green. Red, it only can be 1 and 3 for this intersection. Yeah, product of the three score is 4 or less, and X is odd. Okay, R, it can be 1. So I'm gonna list off the possibilities here. R can be 1, B can be 1, G can be 1. Okay, the multiplication is the multiplication or the product from these three numbers. Yeah, this is 1, and it can be 1, 1, 2, product is 2. It can be 1, 2, 1, product is 2. It can be 1, 1, 3 is 3, 1, 3, 1, 1, 1, 4. It can be 1, 4, 1. Yes, still satisfied. And we have 1, 2, and 2. Yeah, don't forget that. Is also 4. And then I think it's done for R equals 1. And then for 3, this is the only possibilities, I think. Yeah, the product is still satisfied. So we have how many 9 possibilities. Okay, and then I'm gonna add probability of each this list. Yeah, so 111, the probability is 0.28 for the red one times 1/4 square. Okay, for this number, the probability is 1/4 square. I just write 1/4 square. Yeah. Okay, the probability is 0.0175, and for this one is also the same. Yeah, so the 8th of this number have the same probability of 0.0175. That means these 8 possibilities have probability 0.0175 times 8. Okay, and the difference is only for the last list. We have probability of getting 3. You can see in the table is 0.24. So the probability is 0.24 times, I'm gonna write on the back, 0.24 times 1/4 square. This is equals to 0.015, and I'm gonna add with this number. So the result is 0.155. Okay, see this the probability of A intersection B. Okay, and then we still left with probability of B, which probability that X is odd. Probability X is odd is this. Yeah, just sum this number 0.28 and 0.24. Okay, probability of B equals, it can be X equals 1 plus X equals 3. That means we have 0.28 and 0.24. Yeah, so the probability is 0.52. all right, so the result is probability of A given B equals to 0.155 over 0.52, which gets ourselves 0.298 3 significant figures. Okay, let me know if you have any question. You can write it in the comment. Alright, for number 3, a competitor in a throwing event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceed 30 meters. The probability distribution table for x is shown below. Okay, so x equals the number of throws that exceed 30 meters. Okay, given that ex, expected value of x equals to 1.1, find the value of p and the value of r. Okay, so we must use two information. Sum of probabilities equals to 1. Okay, so we have 0.4 plus p plus r plus 0.15 equals 1. So we have p plus r plus 0.55 equals 1. P plus r equals to 0.45. Okay, and then we use this information. Expected value of x equals to 1.1. Remember the formula of ex equals to sum of x times probability of x equals to x, like this. Alright, okay, and then just input this number, 0 times 0.4 plus 1 times p plus 2 times r plus 3 times 0.15 equals to 1.1. Okay, 1.1 equals to, this is 0, p plus 2r plus 0.45. So we have p plus 2r equals to 0.65. Right. And then we use these two questions. I'm gonna solve this simultaneously. P plus r equals to 0.45, p plus 2r equals to 0.65. I'm gonna subtract it. We have minus r equals to negative 0.2. That means r equals to 0.2. Okay, for p, I'm gonna substitute the first equation. 0.45, p equals to 0.25. So we have this value of p and r. For b, find the numerical value of var x. Remember, the var x equals to ex square minus ex all the way square. Okay, remember this difference. Ex square, that means you use the formula of expectation value, but now we use x squared instead of x. So we can do like this: x squared times probability x equals x minus ex. We already have this number, which is 1.1 squared. Okay, and then x squared, I'm gonna square this x and multiply with each of the probability of this associated probability. 0 squared times 0.4 plus 1 squared times p, which is 0.25 right now, 2 squared times r, which is 0.2 right now, and 3 squared times 0.15 minus 1.1 squared. Okay, so this is 0, this is 0.25, this is 0.8, and this is 1.35 minus 1.21. So we get ourselves 1.19. 1.19 aja. Okay, so this is the value of variance of x. Okay, let's take a look at number 4. George has a fair 5-sided spinner with sides labeled 1, 2, 3, 4, 5. He spins the spinner and notes the number on the side on which the spinner lands. Find the probability that it takes fewer than 7 spins for George to obtain a 5. Okay, fewer than 7 spinner is very similar with number 1, I think. Probability of getting 5 on this experiment is, because the spinner is fair, probability of each outcome is 1/5, or 0.2. And then probability that it takes fewer than 7 spins. Probability of x fewer than 7. Yeah. Okay, so we have 6 possibilities. It can be 0, it can be 1, it can be 2, or it can be 6. Yeah, let's see here, 1 2 3 4 5 6. Yeah, oh no, it can be it starts with 1. Yeah, so x can be 1 2 3 4 5 or 6. 1 means he takes 1 spins to obtain a 5. Yeah, so if we get 5, yeah, then he stops. Okay, probability of x equals 1, probability x equals 2, and so on until probability x equals to 6. Probability x equals to 1, that means he got 5 on the first attempt, so we have 1 over 5. And then for x equals 2, it's very similar from number 1. Yeah, for the first attempt he not getting 5, and for the second attempt he get 5, so we have 4 out of 5 times 1 over 5. Yeah, okay, for x equals 2, this 4 over 5 square, because they he not getting 5 on the first and second row. This times 1 over 5, 4 over 5 cubed times 1 over 5, and so on until x equals to 6. That means from 6 attempts he obtained 5 on the last spins, and the first 5 attempts he failed, not getting 5. Okay, so we have 4 over 5 power of 5 times 1 over 5. It gives you 0.738. Is the 3 a significant figure? Okay, George spins the spinner 10 times from the probability that he obtains 5 more than 4 times, but fewer than 8 times. Okay, he got 5 more than 4 times, but fewer than 8 times. Okay, so the possibilities is 5, 6, 7 times. Yeah, so let's say x represent how many times he get 5. How many times he get 5? He obtains 5. Yeah. Okay, so we count probability of x equals to 5, 6, and 7. But for these questions, he already spins the spinner 10 times. Okay, so for those 10 times, what's probability that he get 5 correct, or 5 it's 5 fives? Yeah, and then how many probability of he get 6 5, and how many probability x equals, how much probability x equals to 7? Okay, probability x equals 5. We're following the distribution formula. The binomial distribution formula. X following this binomial distribution, with we have 10 experiment, we have 10 attempts, and probability of success for this context, the success is he obtains a 5, so our p equals to 1 over 5. Alright, and the formula of binomial I already wrote out here. Yeah, where is it? Yeah, somewhere on the top. Okay, so probability is 10c5 times he success 5 times, 1 over 5 times 4 over 5 power of 5. Then 10c6 times 1 over 5 power of 6 times 4 over 5 times 4 plus 10c7 1 over 5 7 4 over 5 cube. Okay, So the answer is 0.0327. It's quite low, yeah. 3 significant figures. Alright, so this is the fourth question, and we're left with the last question. Becky sometimes work in an office and sometimes work at home. The random variable x represent the number of days that she works at home in any given week. It is given that px equals x equals to kx times x plus 1, where k is constant and x equals 1, 2, 3, and 4 only. Drop the probability distribution table for x given the probability as numerical fraction. Alright, so we have this formula of probability x equals x, where x equals to 1, 2, 3, 4, and we can use the fact that sum of probabilities equals to 1. Okay, probability of all x equals to 1. So because we have only 4x, I can write this. Probability x equals to 1 plus probability x equals 2, probability x equals to 3, plus probability x equals 4 equals 1. And then I substitute the 1, 2, 3, and 4 to this formula. So we have k times 1 times 2, yeah, because this is x plus 1. 1 plus 1 is 2. K times 2 times 3. This is k times 3 times 4. This is k times 4 times 5 equals 1. That's nice. Alright, so this is 2k. I'm sorry. This is 6k. This is 12k. This is 20k equals to 1. And then this is 8. This is 20 plus 20. We have 40k equals 1. That means k equals 1 over 40. Okay, and then I'm gonna draw the probability distribution. I write like this. X is probability x equals x. Okay, like this. Have 1, 2, 3, and 4. Okay, for probability x equals to 1, I'm gonna substitute to this k to this, yeah. So we have 2 over 40. I'm gonna still write down like this, yeah. And probability k x equals 2 equals to 6 over 40. Probability x equals 3, 12 over 40. Probability x equals 4, 20 over 40. Okay, and if you doubt about your answer, you can always check the sum of this must be equals to 1. And then find probability of find ex and variance of x. Okay, this is easy, yeah. So just sum x times probability x equals x, like this. So we have 1 times 2 over 40 plus 2 times 6 over 40 plus 3 times 12 over 40 plus 4 times 20 over 40. Okay, so we have 2 over 40 plus 12 over 40 plus 36 over 40 plus 80 over 40. With this one give us 13 over 4, yeah, or this equals to 3.05. Okay, and for the variance, we need to find the value of ex squared first. I'm gonna quick find this value. So sigma x squared times probability x equals to x. So this 1 square times 2 over 4t plus 2 square times 6 over 4t plus 3 square times 12 over 4t plus 4 square times 20 over 4t. Alright, and you have the value of this ex square. We have 26, this is 2, and this is 24, and this is 9 times 12, 108 plus 322 over 40. This is 428. 428 plus 26 give us 454 out of 40. And then for variance itself, this equals to ex squared minus ex all the way squared. And so we have 13 over 4 square, and this gives you 63 over 80 or 0.7875. So this is your answer, and you must get the value of variance must be positive. Yeah, if your answer is negative, you that means your answer is wrong. Okay, so this is the end of our video for today. Okay, hopefully this video helping you to prepare your quiz or your CD or your examination. Okay, see you soon. Bye.